कोई नहीं था, कभी पता नहीं चला, कभी रहा हो और वो आ गया हो, तो ऑल ऑफ अ सडन हुआ, आने के बाद पता लगा।
Good afternoon, ladies and gentlemen. Today we are going to discuss the various ways how we use the SPSS. And in the previous lectures, some of you had, in fact, raised the point that how the SPSS would be utilized to in fact, calculate the various kind of the estimations that we do about the various statistics. So in this lecture today, we shall be covering first the how we shall be calculating the descriptive statistics, and for that I shall tell you the various types of or the kinds of or the various ways how we do the SPSS calculation from the for the descriptive statistics. Then after the descriptive statistics, we shall be discussing the hypothesis testing, the process of the hypothesis testing, how hypothesis is set up, and how the various kind of hypothesis is tested. So to set up the hypothesis and then to test it, the hypothesis, the process and the steps and the phases that are involved in testing a hypothesis shall be discussed. The hypothesis has to be set up and this has to be tested. The hypothesis is basically to test the hypothesis either to be rejected or to be accepted. So in this process, we shall be discussing the process of testing the hypothesis, the steps. Yes. And then we will proceed to the t-tests. So we know that the the t-test is a very important kind of test for the various social sciences research. So in the first, we shall discuss how what is one sample t-test and how it is collected manually and then to be accepted or rejected and accepted. Then we shall discuss the same thing through the application of the SPSS. Once that is done, we shall proceed to a discussion on the two sample t-test, where we shall be first discussing what is two sample test and how these are done. These are basically independent samples. So independent sample t-test we shall be discussing, and the first manual discussion, and then we shall be discussing it through the SPSS. So, and then once it is done, we shall proceed again to the dependent or paired t-test, where the same set of the sample is given a treatment or a any interference, and then the result is noted down, the after effects. And then here we have to check or test whether the any difference that occurs random or it is significant. So again, we shall be discussing it through manually and also through the SPSS. So, ladies and gentlemen, we first begin with the descriptive statistics. How do we arrive for the descriptive statistics? For that, now we shall open the SPSS template, and there I will explain you first how it is done, and then we will discuss the descriptive statistics, how to calculate from the SPSS. So let us go to the SPSS. We are not trying to bring the SPSS on the screen. We are trying to adjust it. The this template is with you, and we have the data variable. We have this two type of templates which you will see. One is the data view and another is the variable view. So what we do, that we first enter the variable name here, and then we enter the next variable name here, and then we enter the next variable name here, and then we go to the data view where we in fact put the in the data view we put the various data about this. And then we will see how to analyze. So first thing is that this uh, template, that is the variable view. In this, we write the name of the variables here, and there rather. We This is the variable view. We name the variables, and then we of course turn to the data view. I will show you the a an example about this. So we have explained you the variable view and data view. I am not, in fact, feeding the data here because it takes time. I have already the feeded data, and I will explain you about. See, we are opening the file which has been, if we have to make a new file, then we go to new and open the data. If we have to open an existing file, we go to open, and then we go to data, and then we click here. Here I have already various the various kind of files here. I will explain you with some files. See, we here, I am taking the file of satisfaction level of students in a class. I click it here. Okay. Then I will click this file. So now I click to open, and see, this file is before us. Here, see, I have already, this is the variable view, sorry, data view, but I go to the variable view. See, here, number one is the satisfaction level of students, okay, from the teaching. Then I have considered item one, that is the various variables which have been taken to understand the level of satisfaction of the students. Here, what is this? Is the class held regularly? That is item one. Then we have the item two, that is, does the class begin and end in time? Then we have item three, that is cross questioning permitted? And then we have item four, that is syllabus covered fully? And then we have item five, that is whether tutorials are held regularly. So this is the variable view, which I have filled here. It is okay. Let me proceed. Now we go here. It is data view. The same will come here. Earlier, it just came on the headings only. Then I took first, second, third, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, 19, and information about 20 students. And then you know what is item 1. It is item 1 is in fact label is the class held regularly, and the students were given a scale of 1 to 5. So here is the various responses of the students, roll number 1 to 20, and they give 1 to 5. They have given their responses from 1 to 5. 1 is minimum, very much dissatisfied, whereas 5 is very well, very much satisfied. So from one to another, the scale. So this is the whether the class held is regularly or not. This information has been given by these 20 students. Then we come to the item 2. What is this? Does the class begin and end in time? So this we have, in fact, again, it is a scale, same scale, and there the students from 1 to 20, they have given their responses, and this has been feeded into this. Hmm. Then we have the item 3. It is the whether the cross questioning is encouraged in the class or not, because it in fact explains the confidence of the teacher, whether he is encouraging the students to ask for questions or not. So again here we have the least the very much dissatisfied, very dissatisfied to very satisfied. Very dissatisfied is 1, then dissatisfied is 2, indifferent is 3, satisfied is 4, and very satisfied is 5. Okay, so this is the information or the data about this which we have feeded here. Then I have the item 4 is the syllabus. So all students have responded here, and they have given their own responses, what they feel. And then we have the item. This item is, are the tutorials held regularly? And again here, the students have given their own version of opinion from the class, and in this we have the information about the gender. So we have here this one. For today, we will not consider the gender, because when we go to the t-test and others, then we will have to be utilize this. So now we are now it may be clear that how the data is feeded into SPSS. SPSS, again I tell you, SPSS has, for this kind of template, it is the variable view, and we have given these item 1, item 2, item 3, item 4, item 5. These are the parameters on which we are going to check the level of satisfaction of students. So here is the class held regularly? Does the class begin and end in time? Is cross questioning is encouraged? Is syllabus covered? And are the tutorial classes held regularly? These are the 5 parameters to judge the 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 satisfaction level, and this we will be using to get today only the descriptive statistics about this. So now it is, we go to the data view. Now it is data. You know that this is the this is the this is the data about this. So I am hopeful that you are able to feed the data, and if there is any problem, I shall again repeat by doing it myself before you. But then today, or maybe in other examples also, when we take another examples about the various tests, then it will be further more clear, but it is not very difficult. As much you practice, as much you will be able to grasp it. So now we have to get the descriptive statistics of these. So what we do, we go to analyze. Click here. In analyze, then this whole template comes. We will click the descriptive statistics. And in the descriptive statistics, first we go to the frequency. We click here, frequencies. Then here a box has come. And in this box, we will put in all the variables. So these 5 variables we shall be shifting to this side. One, then next, we shift this side. This one, shift this side, and 3. This fourth one, shift this side. Then this fifth one, shift this side. So in the list of variables, we have shifted all the parameters that we have fixed for the analysis of the satisfaction. We click at the say charts first. In the charts, let us say we have to make the histogram, and then we click the continue, and then we do the OK. See, the result has come. These are the frequency tables of various parameters, and these are the histograms of various parameters. So you can see the benefit of this software, that what it will take weeks and months to calculate this frequency chart. We get it within minutes, because everything this SPSS does for us. See, this is the frequencies that they have been given in the first table. They give all the information about the whole data. There is no missing data, and of course all the 20 students, they have responded for these 5 variables or parameters. Then we come to the frequency table, and this gives the table about the is the class held regularly, this parameter. The next table gives us, does the class begin and end time? And then the next gives us, is cross questioning encouraged? And then the next gives us the, is syllabus covered fully? And the next gives us, are the tutorials held regularly? So once you look into these details, you will get to find these characteristics. Now we come to the histogram. This is the histogram of the is the class held regularly? Then the next histogram is, does the class begin and end in time? Then the next histogram is about the parameter, is cross questioning encouraged? And then the next is about, is the syllabus covered fully? And then the next is, are the tutorials held regularly? So these are the 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 histograms about our data which we had fed over there. It is not very difficult. We had gone to the analyze, and then we we in fact uh, we in fact just clicked it where we should have clicked. We had clicked at the frequency, and so we got the frequencies. So these are the results which we can save. Hmm? So we do here. Here you have the save contents of output VR to output 1. So you can save or you cannot save. If you want to save, then you have to click yes. And if you don't want to save, then you have to click no. So I click here no. So it is gone. Now, again, we have to get the various descriptive statistics. So we will again go to analyze. Then descriptive statistics in this box, and then we have this next box. We had last time frequencies, and this time we will click the descriptives, and this descriptives we click like this. So again, this box has come. We have to shift these parameters to the variables. So we shift it from here to here, from left box to the right box, then again from left box to the right box, then again from the left box to the right box to the variable box, and again the last one, parameter, to the variable box. Okay, this has happened. Now, next we will click at the options. See, these are the options which we can get. So I have clicked mean, I should get a standard deviation, I should get minimum, maximum, I should get, and also I say click kurtosis and skewness. So these are the things which rather I want to have in the descriptives. They have given you a menu, and whatever you feel you want, if suppose you want to get variance also, then click at the variance also. If we want to get the range also, so we click at the range also. If we want to standard error mean, then we click this also. So this whole menu has been given, and so, and if you want to have sum also, then click the sum also. Okay. So I have ordered on this menu all these items. Okay. Then I will click at the continue. And then I go to the OK. See, this is the box which has come. About the descriptive statistics of all the parameters. So let us see. These are 5 parameters here for which we had collected the information. This gives the n, number of n is 20, that we know. And now we see here all the 5 have the 20 frequency that is given here. Then you see the range is given here, minimum is given here, maximum is given here, sum is given here, and then a statistic, a standard error, a standard deviation, variance, then skewness, and kurtosis, they are all available here. So we got these informations. So we have the mean, we have all these things. So we can either either save it or we cannot save it, whatever we like. So it says whether you want to save or no. I will say no. Once again, I repeat this because it is very necessary. So I again go to analyze, then descriptives, then statistics, then to descripts. I click here. All the 5 are in the box. This time, this go to the option. This time I do not want sum. This time I do not want standard error. This time I do not want kurtosis. This one I do not want skewness. I want only mean, minimum, maximum, variance, range, and standard deviation because I need only these. Then again continue. Then okay. And now we see, I observe that here in the descriptive statistics, what we had demanded, they have given us. They have given us range. They have given us minimum. They have given us maximum. They had given us mean. They have given us standard deviation. And they have given us variance for all these 5 kind of the parameters that we had used for testing the hypothesis. So, sorry, that we had demanded from the SPSS about the descriptive statistics of the data that was with us, about the satisfaction level of students from teaching, say, at AMU. So this was an exercise to get the descriptive statistics. So remember that what we did, we first fed the data. We first have I said, we have 2 templates, variable templates and the data template. We first did the variable template, then we click the data template, and then we feeded the data. And just we feeded the data, then we went to the analyze. And after that, we click at the descriptive statistics. And then after that, we clicked at the descriptives to get these descriptive statistics. And if we had to get the frequency and the or any other information, then we had already got the frequencies where we had got we can get the any kind of chart also. So we now we know how we get the descriptive statistics. So if there is any problem, then I shall be helping you in getting those problems. Now I proceed to the procedure for hypothesis testing. The hypothesis testing is very crucial part of statistics, which helps the researcher arrive at informed decisions in almost every field from medicine, science, economics, and other social science subjects. A hypothesis testing is a statistical procedure to test assumptions about population parameter. It involves formulating a null hypothesis and an alternative hypothesis. Then collect the data, then determine whether the evidence that we got from the data is strong enough to reject the null hypothesis. Whether, meaning that whether the change that has taken place is in collecting data, the difference is because of the random or it is significant. So this we have to check. So the primary purpose of the hypothesis testing is to make inference about a population based on a sample of data. It permits researchers and analysts to quantify the likelihood that observed differences or relationships in the data occurred by chance rather than reflecting a true effect in the population. The hypothesis testing compares two opposite ideas about a group of people or things and uses data from a small part of that group that is sampled to decide which idea is more likely to be true. So, for example, if a company says that its website gets 5,000 visitors each day on average, we can use hypothesis testing to look at past visitors' data and see if this claim is true or not. Before we proceed to discuss the process of hypothesis testing, we should discuss some important terms related to hypothesis testing. Null hypothesis, it is the default assumption that there is no effect or difference. Alternative hypothesis, the hypothesis is that there is an effect or difference. Alternative hypothesis is usually the one, normally is the one which one wants to prove, and the null hypothesis is the one which one wishes to disprove. However, it is not our wish that works here. It is the nature of data which will say what is going to happen. Thus, however, null hypothesis represents a hypothesis we are trying to reject. An alternative hypothesis represents all other possibilities. So the we set up the null hypothesis, we set up the alternative hypothesis with those wishes, no doubt, on the experience of or on the knowledge of the phenomenon that we are researching. Then the significance level is the threshold for rejecting the null hypothesis. It is always set as percentage, usually 5%, which should be chosen with great care, thought, and reason. In case we take the significance level at 5%, then this implies that null hypothesis and alternative hypothesis can be depicted through this. We have you see the lectures, the recorded lectures, we have a table where the null hypothesis is given in terms of mu is equal to mu zero, meaning the population mean is equal to the hypothesized mean. Whereas there are three kind of alternative hypotheses. Mu is not equal to mu zero, mu is greater than mu zero, and mu is less than mu zero. So what is the mu not equal to mu zero means? The alternative hypothesis is that the population mean is not equal to the hypothesized mean. Whereas the alternative hypothesis is that the population mean is greater than the hypothesized mean. And the alternative hypothesis is that the population mean is less than the hypothesized mean. Two-tailed test and one-tailed test are based on the sign in alternative hypothesis. When we have sign not equal to in alternative hypothesis, it is a two-tailed test. When we have greater sign in alternative hypothesis, it is a one-tail right-tail test. And if we have negative sign in alternative hypothesis, it is a one-tail left-tail test. This we will be useful to us when we in fact do things practically. Then the null hypothesis is rejected when the sampling result, that is the observed evidence, has a less than 0.05 probability of occurring if the null hypothesis is true. In other words, the 5% level of significance means that the researcher is willing to take as much as a 5% risk of rejecting the null hypothesis when it is true, and it is usually specified in advance before testing the hypothesis. The p-value is the probability of obtaining the observed results under the null hypothesis. So the p-value is interpreted in the following way. Compare the p-value to a significant level, often at 0.05 or 0.01 etc. The significance level is the predetermined threshold for statistical significance. If probability is less than alpha, it suggests that the difference or effect is statistically significant, and one can reject the null hypothesis in favor of the alternative hypothesis. If the probability is greater than alpha, it is suggested that the observed data is consistent with null hypothesis, which means that there is not evidence to reject it. Thus, the null hypothesis is accepted. Thus, the probability value is used to determine whether the evidence against the null hypothesis is strong enough to warrant rejecting it. Now we come to the critical value. It is also a threshold in hypothesis testing that separates a rejection region from a non-rejection region. It is determined by significance level alpha and the type of test. It is used to compare with the calculated test statistics to decide whether to reject or fail to reject the null hypothesis. The test statistic is more extreme than critical value. The null hypothesis is rejected and alternative accepted. The test statistic is less than the statistically distinct value. The null hypothesis cannot be rejected. Rather, it has to be accepted and the alternative rejected. Thus, the critical points act as a cutoff point on the distribution curve, defining the region whose outcomes are considered statistically significant. What is test statistic? It is a single numerical value calculated from the sample data in a hypothesis test to determine how far the observed data deviates from what is expected under the null hypothesis. It is used to decide whether to reject or not reject the null hypothesis by comparing the data to a standard distribution, which is often used to calculate the p-value. Then we have the type 1 error. It is a false positive in statistical hypothesis testing, meaning that one rejects the null hypothesis, although it is actually true. This leads to an incorrect conclusion that is significantly statistically significant effect or difference exists, but where there is none in reality. The probability of a type 1 error is known as alpha. It may be set to 0.05 or 5%, meaning that there is a 5% chance of making the error. Here we have the type 2 error. It is known as false negative. It is a statistical error that occurs when a hypothesis test fails to reject a false null hypothesis. In other words, it is a mistake of concluding that there is no significant effect or difference when one actually exists. For example, a researcher might conclude that a new drug is ineffective when it is in reality effective. The probability of a type 2 error is denoted by B. The following table depicts the type 1 and type 2 errors which have been given in the recorded lecture. Then we have the statistical power, which is the probability of correctly rejecting a false null hypothesis. In other words, It is the ability to detect an effect when one actually exists. A high power study has a high chance of finding a real effect, while a low power study is more likely to miss one, leading to a false negative. Then confidence interval. It is the range of values that we expect our estimate to fall between if we redo our test within a certain level of confidence. Effect size, it is a measure of the magnitude of the difference or relationship being tested. It refers to the degree or extent of influence of the dependent variable on the dependent variable in a study. Then steps in hypothesis testing procedure. These are the steps. Number one, state the first step. It is the to set up the research hypothesis. The null hypothesis and the alternative hypothesis has this is the first step. These hypotheses will be tested either to be accepted or rejected. Okay? For example, when we want to test whether it is a relationship between gender and height based on our knowledge of human physiology, we formulate a hypothesis that men are on average taller, not taller than women. To test this hypothesis, we state it as null hypothesis: men are on average not taller than women, meaning there is no difference between the height of men and women. And the alternative hypothesis is a one-tail hypothesis: men are on average taller than women. So then select a significance level. We already know the significance level is, what the significance level is. So we take it as 5%. So the next is to collect the data. For a statistical test, it is important to perform sampling if required and collect the data in a way that is designed to test our hypothesis. Test differences in average height between men and women. Our sample should have an equal proportion of men and women. We should collect the data from a variety of regions and social classes. It is available for many countries around the world. Then, what is step 4? Step 4 is perform a statistical test. There are various variety of statistical tests available, but they are all based on the comparison of within group variance, that is how spread out the data is within a category, versus between group variance, how different the categories are from one another. If the between group variance is large enough that there is little or no overlap between groups, then our statistical test will reflect that by showing a low probability value. This means it is unlikely that the difference between the two groups came about by chance. Then alternatively, if there is a high within group variance and low between group variance, then your statistical test will reflect that with a high p-value, probability value. This means it is likely that any difference we measure between groups are due to chance. Our choice of a statistical test should be based on the type of variable and the level of measurement of our collected data. Based on the type, we perform a one-tailed test to see whether men are in fact taller than women. This gives us an estimate of the difference in average height between two groups. A p-value showing how likely we are to see the difference if the null hypothesis of no difference is true. The t-test shows an average height of 175.4 cm for men and average height of 161.7 cm for women, with an estimate of two differences ranging from 10.2 centimeter to infinity. The p-value is 0.002. Then we have the step 5, decision regarding acceptance or rejection of the null hypothesis. Based on the outcome of our statistical test, we have to decide whether to reject or fail to reject our null hypothesis. In most cases, we will let the p-value generated by our statistical test guide our decision. In most cases, our predetermined level of significance for rejecting the null hypothesis would be 0.055%. However, the researcher may choose at 0.01 also. In the analysis of the difference in average height between men and women, we find that the p-value is 0.002, which is below 0.05. So the null hypothesis of no difference is rejected. Then the step 6, presenting the findings. The results of hypothesis testing have to be presented in the results and discussion section of a research paper. In the discussion, we discuss whether the initial hypothesis was supported by our results or not. In another example, we found a difference in average height between men and women of 13.7 centimeter with a p-value of 0.002, consistent with our hypothesis that there does exist a difference in height between men and women. So, ladies and gentlemen, we have discussed the various steps that are involved in the hypothesis testing process. However, this we have to explain by doing a practical by doing practical. So the first thing is the that we will be doing that introducing the t-test and z-test, and after that we shall be discussing the various one sample test to independent to sample test and dependent sample test. And then there we shall be knowing how these are hypothesis tested. So then we go to the recording of lecture number 43, and here we introduce the two tests, that is t-test and z-test. So the t-test and z-tests are commonly used when making comparisons between the means of two samples or between some standard value and the mean of one sample. A t-test is a parametric test applied to identify how the average of two data sets differ when variance is not given. It is commonly employed when dealing with the sizes and unknown population standard deviations. By calculating the t statistics and comparing the critical value, the test helps assess the probability that the observed differences between the two means is due to chance or due to the genuine effect. When the sample size is small, the population standard deviation is unknown, the t-test is used in conjunction with the t-distribution. The number of independent observations in a given set of observations is the degrees of freedom. There are the following assumptions are taken for the test. All the data points are independent. The sample size is very small. The sample size should be taken and recorded accurately. And then it gives the formula for driving t. It is t is equal to x bar minus mu divided by s divided by root n, where x bar is the mean of the sample, mu is the assumed mean, s is the standard deviation, and n is the number of observations. So, ladies and gentlemen, we have given this example. We have solved it whether manually, and this you can see in the lecture that we have set up the hypothesis. The null hypothesis here is that there is no difference between the two means. That is, the training did not have any impact on the data. Then alternative hypothesis was there is difference between the two means, that is, the training did affect the data. Then we calculate this, and after calculating this, we find that for the alpha value of 0.05, the critical value is 1.7. The critical value we have to get from any statistics book where if it is available with us, then at the end of those books, we have a statistical table, and we will show also in some of these how to get the critical value from those tables. So we will compare the calculated value with the critical value. The calculated value here is 5.47, whereas the critical value that we have taken from the table is 1.71. So here the calculated value of t is greater than the critical value, and hence the null hypothesis is rejected, and consequently the alternative hypothesis is accepted. And we conclude that the training did affect the sales rate. Then we have the advantages of t-test, when you can, of course, go through the recorded data. I need not discuss here, and also disadvantage of the t-test. So this also here available in my recorded lectures. Then we go to the z-test. Z-test is the statistical test used to analyze whether two population means are different or not when the variances are known and the sample size is large. The formula is z is equal to x bar minus mu sigma divided by root under 9 n, where x bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and n is the sample size. Here again, we discuss an example which says that, let us say that the mean score of students in a class is greater than 70 with a standard deviation of 10. If a sample of 50 students was selected with a mean score of 80, calculate the z value to check if there is enough evidence to support this claim at a 0.05 significance level. So here we have set up a null hypothesis. The mean score is 70. An alternative hypothesis, the mean score is greater than 70. And now we calculate the z statistics. The calculated value is 7.09. Then we compare it from get the critical value from the table of the z statistic, and then there we find that for a one-tail test it is 1.645. So here the calculated value is greater than the value which the critical value which we have got from the table, and hence the null hypothesis is rejected, and there is enough evidence to support that the mean of the class is greater than 70. So again, you have the advantages of the z-test, advantages of the disadvantage of the z-test. So we have discussed these two tests here, but we need to go to the details of especially the t-test, because you should know that the you should know that the t-tests are very important for the social sciences. So now we introduce and we come to the one sample t-test. We will discuss the one sample t-test, and then of course we will do it manually, and then we will do it through the SPSS also. So we have here the test here. So the one sample test is a statistical hypothesis that can be used to determine whether an unknown population mean is different from a specific value. The test is used for continuous data. The data should be a random sample from a normal population, or the sample sizes should not be too small. The one sample t-test is used to test whether the population mean differs from a fixed value. We have to deal with the question of whether there exists a statistical significance between a sample mean and the fixed value or the set value. This value may, for example, reflect the remaining population percentage or a set quality target that is to be met. For example, we want to find whether the health perception of managers in Canada differs from that of the population as a whole. For this purpose, we ask 50 managers about their perception of health. Again, another example, we want to find out if the SKUs a company produces really weighs 10 grams on average. To test this, we weigh 50 SKUs and compare their actual weight with the weight they should have. A pharmaceutical company promises that its new drug lowers blood pressure by 10 mm in 1 week. We want to find out if this is correct. To do this, we compare the observed reduction in blood pressure of 75 test subjects with the expected reduction of 10 average assumptions in one sample test. The data under consideration must be from a random sample. It must have a metric scale of measurement. The data set is to be normally distributed. Then the hypothesis testing task. In order to perform a one sample test, the following hypotheses are formulated: null hypothesis and the alternative hypothesis. As an example, for the one sample test, we shall examine whether a newly introduced online statistics tutorial at a university has an effect on the student examination results or not. The average score in this statistics exam at the university has been 28 points per year. This was before the online statistics tutorial was introduced. Now the course management wants to know whether the success of the students has changed since the introduction of the online tutorial. Does this online tutorial have a positive effect on examination results? The population considered is all students who have written the economics examination since the new economics tutorial was introduced. The reference value to be compared is 28. Null hypothesis: the online economics tutorial does not have a significant effect on examination results. The mean value from the sample and the predefined value do not differ significantly. Alternative hypothesis: the online economics tutorial has a significant effect on examination results. Then we have here given in the recorded lecture, you will find that these are the students' score. And then the of course the standard, it should be the total test value is 28. So we check it here. The scores are here for 12 students. We calculate manually the mean, the standard error, the t-value. T-value here comes to be 2.74. Then you please get to the page 6 of the recorded lecture. You will find a table which says table 2, critical value of a student's t distribution. This is a photocopy from a statistics book. In any book you have, in the left we have degree of freedom, and then we have the level of significance for two-tail test, then we have the level of significance for one-tail test, and we have the 0.05, 0.02, 0.01. This is the level of significance setup, and for that they have given the value for different degrees of freedom. In this example, we have the degree of freedom as 11. So at the 11 degree of freedom, we proceed. That is 11. And what do we observe here? That level of significance for one tail test is 1.796. at the 5% level. And even at the 0.025 significance level, it is 2.201. So this way we get the critical value from the table. We go to that degree of freedom and then proceed ahead on the right through the rows, and then we choose whether it is level of significance for the two tail. It is, if it is two tail test, then it is the above the top row before we calculate. And if it is something which is one tail test, then we get it from the lower row, and then we proceed ahead, and then we check the critical value which has been given in the table. So here what we find that the calculated t value was 2.74. So in the level of at our as our alternative hypothesis, the two tail test, the critical t value at 11 degrees of freedom is 2.201, whereas calculated t value we had calculated is 2.74, and therefore the calculated value is greater than the critical value, and hence the null hypothesis is rejected and the alternative hypothesis is accepted. Therefore, the online economics tutorial has a significant effect on the examination results. Then this is the second example which is given manually, and then from this we find that it says that the potato yield from 12 different farms is given. The standard potato yield for the given variety is mu is equal to 20. So we have to test whether the potato yield from these farms is significantly better than the standard yield. So it is again a one-tail test. So set up the null hypothesis that mu is equal to 20, there is no difference. And then mu is equal to greater than 20, the yield in these farms are more than the standard yield. We have a degree of freedom 11 and alpha is equal to 0.05 to meet a 95% confidence level. So you go to the calculate t statistic, and in this what we find? We find that we are calculating through various steps, and then we find that the 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 critical value, we have got the t value here. The calculated value is 0.201. So find the critical value from the table. From the table, we are going again go to the 11 degrees of freedom and one tail test. We find that at that point in the table, critical value is 1.796. What we find here, the step 4, we take a decision. What we do here, the computed t statistics 0.201 is less than the critical value, that is 1.796. Therefore, it does not fall in the rejection region. So the null hypothesis is not rejected. The null hypothesis is accepted. So we conclude that the potato yield from these farms is not significantly better than the standard yield of mu is equal to 20. So these are the two examples that we have in fact got from the one sample test manually. Now we will select the examples from the SPSS. So let us go to the SPSS. So now we remove here the existing data. We do not save it. It is already here. Now we again open the data for the we are opening the template, SPSS template again. So listen here, this template is here. We shall go to the file because I have already fed the data and have a file of the data. So I put the file, then it is an open means old file. So go to the open and then click the data. It comes here, all the list of what we have in fact done. We will in fact be choosing a one sample t-test. This is here, we click here, then we open the data. See, this is the score of the students. This is the same example, which was the example one for the manual, what we did the manual. So here, what we have the one sample t-test. We are examining whether the newly introduced online statistics tutorial at the university has an effect on the students' examination results. So here the average test value, that is average score in this statistics exam at the university, has been 28 points per year. This was before the online statistics tutorial. So again, the same way we set up the null hypothesis that the online economics tutorial does not have a significant effect on the examination results. The mean value from the sample and predefined value do not differ significantly. And the alternative hypothesis that the online economics tutorial has a significant effect on the examination results. So you have this score here. What we had done, we had calculated manually. But now here I am showing you how do we calculate it statistically through through SPSS. Yeah. So again, we have the data here. As you are observing, we go to the say variable. Look here. Here I have given to the student's score name X. The label has been given a student score. This is the sample that we will be using for the t-test. Then we have the data view. Data view is this one, that is this, and the same data which we had used for the testing, and then we now do it through the earlier we had done the same data through manually. Then we will do it through SPSS. So we go to analyze. We go to analyze, and then we get to the compare means. Okay, it gives another table in which we have the one sample t-test. So click the one sample t-test. We did here like this. So this has come, a new table has come. It says one sample test. On the left, our score have been given. This we have to transfer to the right. We transfer here. Okay, then we look at the options. Option is all right, 95% confidence, so continue with it. Then we have to give the test value, and you remember that the test value is 28. So we give the test value as 28. This is done, then we do it okay. And now you observe that the result has come. There are two tables. One gives you information about the one sample statistics, that is given in the table 1 about student score. N is 12, mean is given, standard deviation is given, standard error of the mean is given. Then we have the one sample test table. Here again, the test value is shown as 28 because we have to check whether the online, the instruction has benefited students or not. So what we get, that here we have been given the result, students score. We will see the significance of the two-tailed test. One should remember that in the probability, the SPSS does not give one-tailed results. It gives only two-tailed results, significance. So what we do, if we have the one sample test, then simply it will make it half. Okay. So now this has been given as 0.019. It is, since it is a one, it is a one-tailed test. So what we will do, that we will divide this significance 0.19 by 2. So it will come 0.00095 like this. So what we find, that now compare it, and we remember that the critical value are not given by the SPSS. When we did it manually, we used to find the critical value from the table which was given for the critical values. So, but here they give only the probabilities. So we will compare this one-tailed test significance with the probability that we have fixed. So what we have done, we have the at 0.05 we have fixed. So what we find here, that the probability 0.0 0.0095 is smaller than 0.05. So here we have to reject the null hypothesis, because its probability is less than alpha. Then we reject the null hypothesis, accept the alternative hypothesis. And if the probability is greater than alpha, then we accept the null hypothesis and we reject the the alternative hypothesis. So here in this case, what we find, that the probability, and even because if we go to two-tailed test, then of course it says that the mu is not equal to 28 here. So it means that the average is different. The average score is different from the earlier one, that is 28, that we have given the test value. But we have gone in depth whether the online coaching has improved the scores of the students. So what we find, it is a one tail test. We divide the significance 0.019 here, so it comes to be 0.0095, which is, of course, this probability is smaller than alpha. And so what we do, we reject the null hypothesis and accept the alternative hypothesis. And what is that? Therefore we conclude that the online economics tutorial or a statistics tutorial had a significant effect on the examination results of these students. That is the difference between the manual calculation and between the the SPSS calculation that we find here. It is so easy. The only thing is that we have to be very careful while feeding the data, when analyzing it, and also while interpreting it. This would come from the practice. We take another example. We do not save the results output because we remove this, and then we again go to another example. What's now? We go to another example while to do, and this is the potato yield from 12 different farms. So we are trying to bring the SPSS template. Please wait. We are trying to share this template with you. So we are again going to file. We went to the file, clicked it, then we go to the open, and then open the data, click the data, and then here is a list of all the test we have here. So we will take one more example from the one sample test. Here we have the list of one sample test. I'm searching it here. Okay. So see, here is the another example that I am clicking here. I clicked here. Okay. Then I see it came to the file name, and then I open it. Then once I open it, we have this here. And what is here? We have this example of the potato yield of various farms. We have rather 12 farms here, data about 12 farms, different farms, which is given here. The standard yield here is given of 12 various farms. And we have to test whether the potato yield from these farms are significantly better than the standard yield. Okay, and the standard yield has been given as 20. So mu is equal to 20. So at the value of 20, we have to check whether the data about these 12 different forms do differ significantly, or they are just effect of the random or chance. So we will do it here from the SPSS. So this is the data view. You get the variable view also. See here, potato yield, numeric, and all those here are given. Now we click at the data view. The data view gives us this one. This I have already feed it, and maybe if need, then one day I will feed it for you also. Then the next part we have to do. We have to go to the top, and we observe that there are different headings: file, edit, view, data, transform, analyze, graphs, utilities, extensions, window, and help. So what we will do? We will go to the analyze. We go to the analyze. We click here. After that, what we have to do? We have to go for the one sample t-test. So what we do? We do the one sample test. We have this table, and we click the one sample test. This is here. This box has come. which has come in the earlier example also. So this box has come. But let us also uh, set up the hypothesis. Yeah. So the hypothesis that we have set up is that there is no difference between the average production and the threshold, that is 20. And there is the alternative hypothesis that the production by these farms is not equal to the threshold, that is 20, but rather it is greater than 20. It is greater than 20. So we will, the yield in these farms are more than the standard yield. So what we do, we have set up these hypotheses, and then with this hypothesis we have to check from the SPSS whether the yields from these farms, different farms, 12 farms, are better than the threshold or standard of 20 or not. Okay, so we shift this potato yield from this box to the test variable. So we click here. This is potato yield. Go to the test variable. Then we can have the options. In options, we check the confidence interval percentage is 95%. That is alpha is 0.05. So we continue with it. We continue with it. Then we have to fill up the test value. The test value is 20 here. So we write the 20 here as the test value. This we have done. Then we click the OK button, and then it gives the result. The first table that gives us the one sample statistics, that is potato yield. There are 12 fields, n is equal to 12. Mean is 20.1755. Standard deviation 3.02118. Standard error mean is 0.87. So what we have to check, whether this mean is significantly above than 20, the threshold production, or it is just a random or a chance that this mean is different than 20. This will be, we will get from the another table, that is one sample test. So what we do here, we have the test value is 20. The potato yield is here, the difference have been given, degree of freedom, T, and the significance of the two-tail test. What we get here, we get the two-tail test result as 0.845. 0.845. So the probability here is 0.845. Now we compare it with alpha. What we find here, that probability here is greater than alpha. So what does our principle say? That whenever the probability is greater than alpha, that here what we find, it is 0.845. It is of course greater than 0.05. Then here what does it mean? That we accept the null hypothesis that there is no significant difference between the output of these 12 forms from the threshold value of 20. So here we did reject we did accept the null hypothesis, and we rejected the alternative hypothesis that the production at these farms are higher than the threshold production level. So what we find that from the data of these 12 farms, we find that the 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 production at these two farms is not different. A small difference is just because of chance or random, and there is no significant difference between the production at these farms and the threshold level. So now we observe that the what we have observed, that the same thing, the same example that we did is because of the SPSS, it became so easy. The same example we had done manually also in the lecture, recorded lecture number 44. However, in the lecture, the same example we will find that in lecture 45, it gives you with the title One Sample Test Through SPSS. The same example I have given to you has become so easy to test. So this is the benefit of SPSS. I am not sure whether how far I have been able to get this into your minds. It was my duty, but I will expect that you please in the next lectures, you please come prepared with the with questions either from this presentation or from any presentation you like. If I have, I remember, I will give you instant reply. And if at that time I don't remember, then I will beg excuse, and I will, in the next lecture, I shall explain that point to you. However, my only interest is that you please practice it. And I'm not sure whether all of you are having SPSS or not. You can take it, you can either your institution can purchase it, because purchasing is very not easy. So we can take some, they give also for 1 week or 2 week a student, or some for some period of time on a trial basis. You can, for learning, one can take those trial software and then practice it. So please practice it, and whatever difficulties are there, we shall discuss in the next lecture, which will be communicated to you very soon. So with this, I close the lecture, and thank you very much to all. Thank you very much.